So what we want to do today is work on graphing linear equations. But in order to do that, we got to understand a few things. First, what we got to understand is a solution. And if you think of a solution, it's like an answer. So a solution, in this case, is an ordered pair that makes an equation with two variables into a true statement. So there's a few things we got to make sure we understand in there. First, we got to remember what an ordered pair is. An ordered pair is two numbers in parentheses separated by a comma. Let's say our numbers are 2 and -1. Well, if you think back to when we graphed and plotted points, the first value was your x value and it told you how far to walk, and the second value was your y value and it told you how far to climb. So, for example, if this was our coordinate grid, our xy chart, the first value is 2. That means walk 2 places from the origin. 1, 2. The second value is -1. That means climb -1. Well, if I climb negative, I go down. So I would put a dot right there. Okay, so an ordered pair, two values, an x value and a y value. So in our example here, they want us to find the solution, find the answer of this equation right here. But this time they tell you, hey, we want x to be -3. So what we do is we change x into -3. We got to do some substitution. So y equals 2 times whatever x is. In this case, they said x should be -3 minus 1. And we're going to follow the order of operations. Parentheses, exponents, multiply and divide from left to right. So I've got y equals -6 minus 1. And then I have to think -6 minus 1 is the same as -6 plus -1, so y is -7. Now we're not done. We have to write down what our solution is. Remember, solution is an ordered pair. It has an x value, then a y value. The x value for this problem was -3, and I know that because they told us right here. They said make x -3. So when x is -3, y is -7 for this problem. So the solution would be x -3 and y -7. Now there's actually lots of solutions to that equation. First they told us x was -3, but what if they said, you know what, we want x to be +2? You would do all the same work. You would substitute whatever they tell you x should be. So y equals 2 times, this time they said make x 2 minus 1. Y equals 4 minus 1, so y equals 3. So our x value on this one, they said make your x value 2, and your y value is 3. So another solution is 2, 3. There are lots and lots of solutions to that equation. It just depends on what they want x to be. So always important to read it and find out what x is supposed to be. So in this example, they said, you know what, let's make x -1. So I'm going to substitute -1 in for x. And when x was -1, y is +1. So we write our solution, remember, in parentheses. We have an x value and a y value. They said your x value is -1. If your x value is -1, your y value is +1. So the solution for this one is -1, 1. Your job is to try all three of these. It says for all three of them, substitute -3 in for x. So try all three of them, pause the video, then start the video back up when you're ready to check your answers. So in letter A here, y equals 2 times, well, they wanted x to be -3 plus 1. So y equals -6 plus 1, and y would then equal -5. Now I'm not done. I have to write my solution. The solution, in this case, when x is -3, y is -5. Do the same thing on the next one. Y equals -4 times, they want x to be -3. Substitute it. Now do your order of operations. Y equals 12 plus 3. Y would be 15. Again, not done until you write your solution. Your solution, we have an x value and a y value. They said the x value is -3, so the y value is 15. And on the last one, y equals 0 times x, negative 3, minus 4. Y equals 0 minus 4, so y equals negative 4. Your solution, when x is negative 3, y is negative 4. Here's a real example of how a two-variable equation would work. A stands for the acres, and to figure out the number of acres, we take 640 times the number of square miles. Well, it tells us that Sally owns a lot of land. She owns 12.5 square miles. So 640 times, says change S into 12.5. So you'd probably have to do a side problem. Now's a good time to pause the video, do a side problem, and then come back and see what you get. So if you've done a side problem, 640 times 12.5 gives us 8,000, and you maybe have 8,000.0, means the same thing. That means Sally would own 8,000 acres of farmland, which is a lot of farmland. All right. How do we use all this stuff? Well, all this stuff helps us to make a linear equation. And if you look at the base word in linear, it says line. A linear equation is any equation whose graph is a line. And one thing I like to add to that, a straight line. And a straight line sometimes will be horizontal and sometimes will be vertical, but most likely when we're working with linear equations, your straight lines are going to be diagonal. And it doesn't matter what steepness they have. Okay? A straight line cannot be curvy like this. That doesn't work. A straight line cannot turn corners like that. Straight line has to just be straight. It can be up and down, it can be left and right, but most likely it's going to be diagonal for us. So linear equation. Let's practice. How do we graph a linear equation? Well, here's our first example. It says graph this equation, y equals 3x plus 1. I'm going to rewrite it down here. Y equals 3x plus 1. Excuse me. Now, earlier they said change x into this, change x into this. But since they didn't tell us this time, we get to make x whatever we want. And a way to keep this organized is to make a table of values, what I call an XY chart. Now, we get to make x whatever we want. Well, since we get to pick our numbers for x, let's pick easy numbers. I don't want to pick decimals or fractions or even negative numbers. I want to pick easy numbers for x, like 0 and 1 and 2 and maybe 3. Okay? I want to pick easy numbers because I know I have to substitute those in for x. So the first one, it says, let's change x into 0. So it says y equals 3 times 0 plus 1. Y equals 0 plus 1. So y would be 1. So when x is 0, y is 1. Now, that's an ordered pair, 0, 1. Remember, the first value, x, tells you how far to walk. And the second value, which is your y value, tells you how far to climb. So I would, from the origin, walk 0 and climb 1. And I would put a dot there. The next one says let's make x into a 1. So again, I'm going to do a side problem where I change x into 1 and solve it. When x is 1, y is 4. Again, that's an ordered pair, 1, 4. That means I'm going to walk 1 from the origin and climb 4. 1, 2, 3, 4. So now I'm way up here with my next dot. Now if you think back, solution. So far we have two solutions to this equation. The first solution was 0, 1, and when I put it on the graph it's right here. The second solution was 1, 4, and when I put it on the graph it was right here. Let's get another solution. This time it says change x into 2. So I'm going to do a side problem where I change x into 2. So y equals 6 plus 1. Y would be 7. So that means when x is 2, I walk 2, right? 2 comma 7. The first value is walk. Walk 2. Climb 7. 1, 2, 3, 4, 5, 6. 7 would be right about here. It is okay to go off the chart because remember, A graph goes both directions, left and right, up and down, forever and ever and ever. If I substitute one more number, this time I'm going to substitute in a 3. Y equals 3 times 3 plus 1. Y equals 9 plus 1. Y equals 10. Now if x is 3, y is 10. 3 comma 10. So from the origin, walk 3. 1, 2, 3. Climb 10. 3, 4, 5, 6, 7, 8, 9, 10. I'm going to be way up there. The next thing we need to do is grab a straight edge. So you might use the edge of a book or a ruler. I happen to have a straight edge tool up here. And I want to connect all my dots. And in fact, I want to extend as far as I can. And then I need to put arrows on the end. Now, what does all that mean? All that means is that every dot on this line is a solution. We already proved that this green dot was a solution, this blue dot was a solution, this red dot was a solution, this black dot is a solution. But a line is made up of billions and billions of tiny, tiny dots. So everything on this line is a solution to that equation. So what we're going to do now is practice a little bit. There are two parts to each of these problems. The first part says graph it. So to graph it, remember, you're going to take this equation, you're going to make an XY chart. I suggest you do 3 points, at least 3. You can do more if you want. And again, you get to pick X numbers that are easy for you. Easy numbers for me are 0, 1, and 2. Now is a good time to pause the video, fill out the rest of the XY chart, and practice graphing it on your graph, and then we'll talk about the rest. Okay, so the first part, substitute and graph. So I'm going to substitute in a 0 for x, and I know that if x is 0, y is 1. If x is 0, y is 1. I'm going to come over here real quick and graph that. The second point, when x is 1, y is 1. I made a mistake here. I got to go back. When x was 0, y was negative 1. My fault. So when x was 0, y was negative 1. Now I can go to the second one. When x is 1, y is 1. So I'd get this point right here. Third one, when x is 2, y is 3. When x is 2, y is 3. 2, 3. So when x is 2, I walk 2 and I climb 3. 1, 2, 3. Okay, I have at least 3 points and they connect nicely in a nice straight line. One thing I've noticed is that there's a pattern here. When I climb 2 places and go to the right one, I get to the next dot. Climb 2 places and go to the right, I get to the next dot. So I can put some more dots on there. And I can even go in reverse. Go down 2 and left 1, and down 2 and left 1, and down 2 and left 1. Now I have a lot of points. It makes it a lot easier to make a straight line. All that work was for the first part, where we graph the linear equation. Here's the second part. Is the given value a solution? The given value is this point right here. They want to know, is that a solution to this equation? Well, remember, the first value is x and the second is y. So what they want us to do is substitute negative 2 for x and negative 5 for y. So y is negative 5 in this case, equals 2 times x, which is negative 2, minus 1. Negative 5 equals negative 4 minus 1. Negative 5 does equal negative 5. That works. So is the given value a solution? Yes, this is a solution. So look at all the work we had to do for letter A. Your job is to do all that work on letter B and come back and see if it works out for you. Okay, real quick, let's check letter B. I made my XY chart. When x was 0, y was 2. When x is 0, I walk 0 and I climb 2. Got it. When x was 1, y was negative 1. So I'd walk 1 and climb negative 1. When x was 2, y was negative 4. So I'm going to walk 2 and climb negative 4. 1, 2, 3, 4. I've got at least 3 dots on there, and I see a pattern. It's climb 1, 2, 3, and go backwards 1, 1, 2, 3, and go backwards 1, 1, 2, 3, and go backwards 1. I'm going to put another dot, and then I'm going to connect the dots. Those are all solutions. Now they wanted me to check. Is this a solution? I substituted, they're not equal, so no, that's not a solution. In fact, 3, negative 4 doesn't fit on this line. That's another way to know. Walk 3, 1, 2, 3. 1, 2, 3. Climb -4, 1, 2, 3, 4. I'm